Howdy, my name is Forrest and I love SQL Server. Well, anybody crazy enough to make a YouTube video about SQL Server probably really loves SQL Server. Or really hates SQL Server. This is the internet after all. But anyways, I really do love it, and I especially love fixing slow queries. And one of the common slow queries that I'm asked to fix is a slow delete. A developer may ask me, Forrest, why is this delete so slow? It's only getting rid of a couple dozen rows. Why is the database so bad at this? Well, let me show you. I'd say that 90% of the time I run across this type of slow query, there's the same root issue. Let's start with a demo. So I copy the votes table and the posts table from the Stack Overflow 2010 database into my own test database for this. Millions of rows. Let's start with a delete. So here I pick 5 values and I put this delete statement within a transaction and roll it back at the end just so I don't actually get rid of those rows. Let's see how fast this is. I have actual execution plans turned on. Good. Here we go. Boom. That was fast. If we look at how long that took, you see that 0 seconds there? We can double check that with the query time stats. This was faster than a millisecond. All right? This was really, really fast. All right? So what if I look at those post and votes tables and I realize, oh, I should add a foreign key relationship. In the votes table, there's a column called post ID. I want to make sure that that post ID in the votes table only references IDs in the post table that actually exist. All right? And the way I'm going to enforce that is with a foreign key. So here we go. We're going to add a foreign key. Great. Let's try this delete statement again. All right, remember how fast it was before, less than a millisecond? Oh, surely it can't be too bad. Oh, this is taking a while. Oh, there it goes. All right, so we went from less than a millisecond to more than 5 seconds. That's really slow. That's a lot slower. This would probably be worse if I were deleting even more values. What's going on? Well, remember that the foreign key is there for a reason. It's to enforce that the post ID value in the votes table never references a missing ID in the posts table. All right, so when we get rid of rows in posts, SQL Server has to make sure that the foreign key relationship remains true. And so what it does is it looks through the votes table to make sure that nothing is referencing the soon-to-be deleted post ID. All right? Let me show you what happens if there is a match. We'll pick ID equals 42. We'll try to delete, and we get the delete statement conflicted with the reference constraint. All right? And the transaction does not succeed. All right? It doesn't let you do that. So what's happening here, we'll let it run again. 5 seconds of boredom. All right, what's happening, every time we get a row, it gets deleted, and then SQL Server will check the entire votes table. All right, we see this clustered index scan, and we see that it's occurring 5 times. This is scanning millions of rows. This is a lot of work. What can we do to fix it? Well, we can follow best practices and put an index to support your foreign key, which you should pretty much always do. Let's add in this index. All right, index is in there. Let's see how the delete does. All right, 5 seconds. What's it going to be? From 5 seconds down to fast again. Instead of having to look through the entire votes table, now that we have an index on post ID, SQL Server can look for the specific value very quickly. It makes this delete fast again. All right, let me just make sure to clean everything up and call it done. Thanks for watching. Index your foreign keys.